we get started, we're going to look at yesterday's homework, problem number 45 first. Y is equal to log base 2 of x. Now, luckily for all the ones on the homework problem, we did not have f of x. Since we did not start in function notation, we won't end in function notation. So if it had started out as f of x, g of x, h of x, we would have ended with f inverse of x, g inverse of x, or h inverse of x, respectively. But here it started out as y equals. We're going to end in y equals. Now, the first thing we want to do with finding the inverse is switch x and y, because the inverse is flipping the input-output. Because for a function's input, it takes it to an output. An inverse takes its output back to the input. So we switch that domain and range, the x and y. The next thing we want to do is solve for y. We want to get y by itself. Now, we need to get it out of this logarithm. And to do that, we can use our switching method, which was the log base b of y equals x if and only if b to the x is equal to y, to go about that there. Or as we went over yesterday, if the base and the base of the logarithm are the same, so 2 to the log base 2, since these match, this entire side will simplify to just what's inside the log, which would be y. But if I put one side to the base of 2, I have to put the other. And 2 to the x does not simplify. So that tells us that the inverse of log base 2 of, or y equals log base 2 of x, is y equals 2 to the x. And that's it. Questions on 45. 49. Y equals e to the 3x. Already in y equals, so we don't have to switch it to y. So the first main thing we can do is switch x and y. Flipping the x and y. That's all we're doing first. Now we need to get that x, or that y, out of the exponent, because we need y by itself, and trying to get it out of the exponent is going to be the big first step. And to do that, we can do that switching method. For this here, the natural log of y equals x if and only if e to the x is equal to y, or vice versa, however you want to put the letters. Or, because the base is e, I'm going to apply the natural log to both sides. On the left-hand side, the natural log of x is just, well, the natural log of x. It does not simplify, it doesn't reduce, because x could be any number, any input value. The natural log of e, well, the base is understood to be e, so it's going to simplify and leave us with what's inside the exponent. So we have 3y. So we say that the natural log of x is equal to 3y. So we got y out of the exponent. That was the big first step. Now we need to get y by itself. And to do that, we can divide both sides by 3, telling us y is equal to the natural log of x over 3. And that's perfectly fine. We can divide a log by a number. We can actually divide two logarithms by each other. Because I could have the natural log of x divided by the natural log of 3. That's perfectly fine. Because, again, when we start putting numbers in for x, the natural log of that number is just a number. It's just a term. We can multiply and divide them. Any questions on this here? All right. Any other questions over the homework? What we're looking at today is straightforward and can be complex at the same time. It's simple and complex. And I think at this point we've seen a lot throughout this semester and last semester of stuff that is simple and complex all at the same time. Because if we're trying to do it and start mixing up what we're doing, it makes it harder and harder on ourselves. And what we're looking at today are properties of logarithms. These properties are helpful in not only just being able to condense and pull it apart, push it back together, but also solve. Because if we're looking at more than one logarithm, there's different properties to them that help us be able to solve them, make it work nicer. And the first one's product property. And the product property says if we have two things multiplied together inside the logarithm, I can write it as a sum of two logs. So if I have two things being multiplied together, I can write it as both of those logs being added together. Interestingly enough, if I have two logs with the same base being added together, I can rewrite it as a single log with what's inside being multiplied. We also have our division, our quotient property says if I have two things being divided inside the logarithm, I can rewrite it as a subtraction. Or if I have two logs with the same base being subtracted, I can condense it down and write it as one log with what's inside being divided. And finally, the quotient, or our power property. Power property says if I have an exponent inside the log, I can move it to the front and say n times that amount. These three properties are very helpful, especially with solving and reducing and simplifying. And what we're mainly going to be looking at today, we're not actually solving anything today. We're taking these logarithms and expanding them and condensing them. Now, when we expand a log, the first property we want to use is our quotient. Our quotient property, our division property. When we're expanding, the first property we want to use is quotient. If two things are being divided inside the log when we're expanding, we want to do that property first. That's the first one we want to tackle. If there is no division inside the log, we don't have two things being divided, we go straight to step 2. But as we look at the first one here, it wants us to expand the natural log of 5x to the 7th divided by y. We do have two things divided inside the logarithm, and according to the quotient property, I can rewrite it as a subtraction of those two terms. So for us here, we're going to have the natural log of the numerator minus the natural log of the denominator. The natural log of the top minus the natural log of the bottom. And the numerator for us here is 5x to the 7th. And the denominator is y. So according to the quotient property, we can split this up into the natural log of 5x to the 7th minus the natural log of y. Questions on this here? In either one of these two logs that we have now, is there any other division happening? No. Most of the time we won't have it because they're not going to have a fraction inside of a fraction inside of this log. It's just going to be one of them. Straight, let's switch this to red. Our second step is going to be product. Our product property. If we have two or more things being multiplied inside the log, we can rewrite it as a sum of those terms. We do have to be careful, especially for like here, if the natural log of y had more than one term, all of those terms, that minus is going to have to be distributed across it. If a term is in the bottom of a fraction when it's fully expanded, each one with a minus should end up in the bottom. But here, the only spot we have a product is in our first one, that natural log of 5x to the 7th. So we can rewrite this as a sum because we can have the natural log of 5 plus the natural log of x to the 7th. If there was 3 terms in there, we'd have the natural log of the first term plus the natural log of the second plus the natural log of the third minus natural log of y, because it's still going to be there. Questions on the first or second property? Well, we know it has to be next. This is going to be our power property. And the last one is our power property. Any of the exponents move to the front. And we only have one in this one that has an exponent. That's our natural log of x to the 7th. So the natural log of 5 is going to stay the natural log of 5. But the natural log of x to the 7th, that 7 is going to move to the front. So we have natural log of 5 plus 7 natural log of x minus natural log of y. And that's it. So we know, so question is, when do we know we have the answer? So when we look at this here, I look at each of the logs and see if I can reduce it or simplify it. Now, x and y, natural log of x, natural log of y, there's nothing left being multiplied together. There's nothing left being divided. There are no exponents. I'm done. Numbers with natural logs, unless that number is e, we're done. Now, we could have some, I'm not going to make y'all do this, but if it was, say, the natural log of 6 and it wanted it all the way down, 6 is 2 times 3. So it's natural log of, I'll write it here. Yeah, so it'd be, this natural log of 6 is 2 times 3, which is the natural log of 2 plus. Could do that. Doesn't help, doesn't make things easier. Even if we had that, I'd just say leave it natural log of 6. You're not making things easier. However, if it was, say, the natural log of e was there, well, the natural log of e is just 1. Because just the natural log of e to the first power is 1. So if it simplifies down, it reduces nicely. And when I say nicely, we have an integer number. They would want us to reduce it. Otherwise, we'll just leave it. The natural log of 5 is not a nice number. Questions on these here? Any other questions? Because that's a good one. Let's look at the second one. The natural log of 3x to the 5th divided by y. First thing we always look for is quotient. Won't always have it, but since it does, we can rewrite this as the natural log of the numerator minus the natural log of the denominator. So we have the log of the numerator minus the log of the denominator. Right, because at this point here, we do have a product in the first one. So we can use the product property to split those up as a sum. So it'd be the natural log of 3 plus the natural log of x to the 5th minus the natural log of y. 3 is not going to simplify no matter how we do it, at least not simplifying nicely. However, the natural log of x to the 5th, according to the power property, we could take that exponent and move it to the front. telling us that we're left with the natural log of 3 plus 5 natural log of x minus the natural log of y. And that's it. Questions on these two here? Question on anything we've done so far? Number 5, log base 6 of 3x to the 4th. Now we said the first step in expanding this is quotient property, yes? What's being divided in this log? Nothing. So do I have to do the quotient property? No. Could it happen that I don't have a quotient or product? Yeah, we just have a single term. Then we just go to power and we're done. Here we do have a product, the 3 and x to the 4th. So according to the product property, I can rewrite this as a sum of logs with what's inside. So we have each of those terms of 3 and x to the 4th. So log base 6 of 3 plus log base 6 of x to the 4th. The bases for each log are going to be the same. Then our power property says we move that exponent to the front, telling us that we have log base 6 of 3 plus 4 log base 6 of x. That's our final answer, because we could check and see if log base 6 of 3 simplifies, if it reduces. It doesn't, because if it could, we would have to be able to multiply 6 by itself a certain number of times to get 3. Because square root of 6, there is no square root of 6. There is no power that we can put 6 to get to 3. That is a nice integer number. There's an irrational number that works, but not an integer. Because if it had been, say, log base 6 of 36, 6 to what power is 36? That'd be 2. We would rewrite it as 2 plus 4 log base 6 of x. Question on number 5. We good with these so far? We ready for number 6? Now extra log of 5 over 12x. This one we do have a quotient, yes? So, quotient property says we can rewrite this as a difference of the numerator and denominator. So according to the quotient property, we can rewrite this as the natural log of 5 minus the natural log of 12x. Questions on this so far? Natural log of 5 is as simplified as it gets. Natural log of 5 only has one term, no exponents, and the natural log of 5 is not a nice integer number. However, our natural log of 12x does have a product. We can rewrite it as the natural log of 12 plus the natural log of x. But we do have to be careful. That negative has to go to both. That negative has to go to both of them, because we're saying negative natural log of 12x. Well, 12x, that natural log of 12x is the natural log of 12 plus the natural log of x. But it's being subtracted from our natural log of 5. Both of those are being subtracted. Both of those need that negative. So really what we have is the natural log of 5 minus the natural log of 12 minus the natural log of x. Because when we do that product property, we're just replacing that natural log of 12x with the natural log of 12 plus the natural log of x. we put those parentheses around it because that negative is not just applied to the natural log of 12. It's also being applied to the natural log of x. Kind of an interesting note, whenever we have those minuses in front of the logs, it's telling us those terms are on the bottom of the fraction. They should be in the denominator. Since we have two terms in the denominator, we should have two logs with minuses in front of them. Does that make sense? And actually, if a problem like this showed up on the ACT, that's actually nice to know. Because I see here it wants me to simplify this down. 12 and x are both in the denominator, which means its versions of logs should both have minuses in front of them. And there's a good chance they're going to write it, at least have one answer choice like this here. Because we haven't been putting them up to this point, because here I could have put the parentheses around the natural log of 5 plus the natural log of x to the 7th. Nothing in front of it, no sign in front of it, so they just drop, they go away. But because of that minus, we had to put them to make sure that minus was distributed through. Questions on these so far? The other thing we can do is condense. We can put this back together. We can condense it back. Let's put this in. Condensing. And like most things, when we expand, we go A, B, C, 1, 2, 3, quotient, product, power, and in most other cases, when we go the other direction, we just go back up the chart. We get finished, we start with what we finished with, we end with what we started with. That's in everything that we do. Yes, we take something apart, we start with the first step, end with the last. When we put it back together, we start with the last, end with the first. So the first part of condensing is going to be powers. Take negatives with powers. Take the negatives with the powers. Because I've worked through this a good amount of time, trying to figure out best ways to do this. And the issue is not so much with the negatives. It starts coming when we look at quotient, that quotient property. Because we start getting fractions inside of fractions, and now we've got to simplify the fractions and work through it. And I figured, in kind of as doing this, with the power property, if there's any negatives, take them into the power. As we look at this here, log base 9, there's not a number in front of it, so there's not a number we're moving back up into the exponent. It's just log of 9. Yes. Now the second log has this 3 in front. So our power property says we're going to move that 3 back up into the exponent, which is fine. We can see that, just the opposite of what we did with powers. However, I'm going to take this negative and move it up. So it's going to be plus log of 3. And we would have that negative because we took that negative up into the exponent, which changes it to a plus. But what would that number be? What would the number between that negative and log of 3 be? It's not written, so it's understood to be 1. Because if there's not a number written, it's understood to be 1, so we're pulling this negative 1 up. And it doesn't seem like this is a big step, a big change, but it does help things out a significant bit. because by pulling that negative up, I've actually removed a property that we have to work with, we have to use. Because our quotient property said if I have two things being subtracted, I can rewrite it as 1, bless you, with what's inside being divided. Do we have subtraction in this anymore? So that means we don't have to worry about quotient. We just have to go to second property, which is our product. Our product property. We do have two or more things being added together. We have two or more logs with the same base being added together. So we can rewrite them, we can condense them into a single property, or single log, with what's inside being multiplied. Now we don't have to worry about subtraction, or our quotient property. Now we just need to simplify this and fix our powers where needed. Since we have 3 to the negative first power, to get that power to be positive, we cannot leave exponents as negatives. We have to move it from the top of the fraction to the bottom. So it's going to take it from 3 to the negative first power to 3 to the first, or just 3. We'll leave 9 alone for now. 2 to the third. 8. 2 times 2 is 4, times 2 is 8. 2 to the third power is 8. So we have 9 times 8 over 3. Wait a minute, 9 times 8 over 3. We could do 9 times 8, which is 72, and then divide it by 3. Either way, because 9 divided by 3 is 3. 3 times 8 is 24. So that tells us it's the same value as log of 24. Questions on this one here before we look at the next one? Let's look at the next problem. Log of 6 plus 4 log of 3 minus log of 3. So the first property we want to do, we want to apply is our power property. Now it's not going to change log of 6. There is no number in front of it. There's no exponent property we're going to apply to it. But we can move the 4 up into the exponent, telling us that 4 log of 3 is going to become log of 3 to the 4th. And I also want to take this negative with it. And because there's not a number written between that negative and log, it's understood to be 1, so we're bringing negative 1 up into the exponent. Questions on this so far? We have 3 logs that are being added together. According to the product property, we can rewrite this as a single log with what's inside being multiplied. So log of 6 plus log of 3 to the 4th plus log of 3 to the negative 1st can become log of 6 times 3 to the 4th times 3 to the negative 1st. I don't know about y'all, if there's times that we can do stuff simpler, we can do stuff nicer, it's always easier and nicer to do those things, yes? What's inside that log does need to simplify. We need to finish reducing it, yes? Is there a single variable inside there? Because we have 6, 3 to the fourth, and 3 to the negative 1, yes? Is there a variable? No. Now, we're not going to type the whole thing in. We're not going to type log of 6 times 3 to the 4 times 3 to the negative first. But can the calculator tell me what 6 times 3 to the fourth times 3 to the negative first is? It tells us it's 162. Because 3 to the fourth is 81. 3 to the negative first power is 1/3. So really we're saying 6 times 81 times 1/3, or 6 times 81 divided by 3. 81 over 3 is 27. 81 divided by 3 is 27. And 6 times 27 is 162. So really we're just saying that this is log of 162. Now we would reduce this further if it reduced nicely. But unfortunately, log of 162 does not reduce nicely. If we wanted to make sure, I can ask the calculator what log of 162 is, and it's 2.209515015, so on and so forth. Questions on this here? We're ready for the next one. The quotient property? Yeah. So the first step we started with expanding was the quotient property. So when we condense, it feels like we should do the quotient property last. But because we take the negatives as a part of the power property, we've removed the quotient step completely. So log base, but also if the base of the logarithm is 10, we just press the log button. Yes. Questions on this here? Now, I will say, taking that negative up into the exponent, for the most part, is a nicer step. There is an exception, and it's number 7. Because I'll show you the main steps using this here, taking the negative, because if we do that, I don't see any exponents, but we can bring that negative up into the exponent, which tells me that I have log of x plus log of 9 to the negative first power. Since we have two things being added together, we can rewrite this as a product. So we have log of x times 9 to the negative first. I can't leave that as 9 to the negative first. We've got to take it from the top of the fraction to the bottom, which tells us that we have log of x over 9. Although the quotient property takes us from step 1 to the answer immediately. So especially when we have more than one term, we have more than one that have a minus in front of it, taking that negative up into the log, or taking it up into the exponent, works a lot nicer than this here. Questions on this here? Number 8, natural log of 4 plus 3 times the natural log of 3 minus the natural log of 12. Here, the first thing we want to do is our power property. Now the natural log of 4 does not have any numbers in front of it, doesn't have any signs in front of it, so it's just the natural log of 4. Our middle term, this 3 times the natural log of 3, we're going to take that 3 up into the exponent, telling us that we have the natural log of 3 cubed plus the natural log of 12 to the negative first power. Questions on this here? Now we have 3 things being added together, so we can rewrite it as a single log with what's inside being multiplied together. So we have the natural log of 4 times the 3 cubed times 12 to the negative first power. And again, at this point here, we can grab that calculator, not type the whole thing in, but we can type in 4 times 3 squared times 12 to the negative first, and it would give us, bless you, I believe it would give us 9. Now, the part of the reason we get there, because if we work this out, I would move that 12 from the top of the fraction to the bottom. Now I'm going to continue just kind of working this out, writing this out. 3 cubed is 27 over 12. 4 times 27, 8, carry the 2, 8. And 108 divided by 12 is 9. And we can simplify it down. We can work it out. The calculator will do it for us. Now, part of the reason or the way I said it's 9 is because when we look at the numerator, 4 times 3 to the third, 3 to the third just says we're multiplying 3 by itself 3 times, yes? I'm going to take one of those 3's and multiply it with 4. What's 4 times 3? We don't have 12 on top and bottom? So they would cancel out, leaving me with 2 3's on top, 3 times 3, which is 9. Questions on this here? Now, the last part of the note sheet, I believe, is this here. Now, we're going to, most likely, we're going to save this till Monday, and that's fine. It will give you some time to work on the other assignments and how it ends up working out. Now, for the most part, until we got actual calculators that can do logs and solve logs, we needed ways to actually find values, especially if we don't have a system to do these. Really, they're complicated setups to find these logs because it's a lot of guessing, approximations, so on and so forth. But what we did have, and what most had, was something called log tables. It's this big sets of numbers, and we would use it and reference it to find the values of logarithms. They did not have every value because pieces of paper, or especially, as we can see, something like this here, is a lot of data and a lot of information that takes up a lot of space. So if we have methods and ways to simplify this down and make it easier, that's what we did, and that's why these expanding and condensing logarithms becomes helpful. So just like this here, log base 2 of 3 is 1.585. And log base 2 of 7 is 2.807. If I can rewrite whatever the log I'm trying to figure out in terms of base 2, base 10, I can actually find out what the value is without actually having to use a calculator. I can find these approximation values. But we'll do that on